Now this question shows a sector, and what we've got to do is calculate the area of the shaded region as a percentage of the area of the sector. So that's where we're aiming to get to. So let's first of all mark on what we know. Now I think the place to start here, it says we've got an equilateral triangle of side 7. So that's our AOOB. So I'm going to put 7 centimetres there, 7 centimetres there, and 7 centimetres there. Now, if this is an equilateral triangle, all the angles in this triangle are all going to be 60 degrees. And that's one of the key things in this question. Now, the radius of this sector, that distance there, that's going to be 11 centimetres. So that bit there's 7, that's 11. So that bit there must be 4. That might help us, I'm not sure. So the first thing I'm going to do, I'm going to calculate the area of the sector OQN. So I'm going to put area sector, well they've got it here, ONQ, equals, what fraction of the circle have we got? We've got 60 out of 360 degrees, so that's our fraction of the circle, times pi times r squared. Now the radius of the sector is 11, so it's times 11 squared. So I'll just sort that out on the calculator. So we've got 60 times pi times 11 squared equals, and I'm just going to leave it like that there, 121 over 6 pi. Let's call that number 1. The next thing I want to do is I want to find the area of the triangle. This is the equilateral triangle AOB. And the thing we're going to use to do this is the formula. Remember half AB sine C, which is the formula that you're going to use. So if you think to use that formula, what you usually have is you have a triangle with an angle C that you know, and in our case RC is going to be 60 degrees. So imagine these other two sides would be A and B. Well, these are going to be our 7 centimetre sides. We know the two sides that surround the angle, and that's when you use this half AB sine C formula. So the area of this triangle is going to be a half times 7 times 7 times this angle here on the triangle, sine 60 degrees equals, so let's do that on the calculator. So we've got 0.5 times 7 times 7 times sine 60, I'm just checking the calculator was in degrees, equals, and that should come to 49 root 3 over 4. I'm just going to leave that as number 2. Now let's have a look at what the question wants us to do. It wants us to calculate the shaded area as a percentage of the area of the sector ONQ. So what's the shaded area going to be? So that the shaded is going to equal the sector area, which is number 1, take away number 2, so take away that triangle, and then we need to put that over, divide it by what's the area of the sector, that's going to be 1, and then to make that as a percentage we're going to times that by 100. So I'm just showing there what we're going to put in on the calculator. So the percent shaded is going to equal 1 take away 2, so 1 is 121 over 6 pi, take away our 2, there's 49 root 3 over 4, divided by number 1 was our area of our sector, 121 over 6 pi, and then we're going to times the whole lot by 100 to get it as a percentage. So let me do this as one big calculation on the calculator. So I'm going to get fraction 121 over 6 pi minus, well, let's start again because I'm going to need a fraction on the bottom as well. So I'm going to put fraction line and a fraction up here. 121 over 6 pi minus fraction 49 root 3 over 4. Arrow down to the bottom. I want a fraction down here as well. 121. Let's put pi over 6. Arrow to the right, and I'm going to times the whole lot by 100. And that comes out as 66.5101. So I want to get that to one decimal place, so my answer is going to be 66.5 to one decimal place.